Okay, welcome to another video. Today I want to talk about some calculation on resistors with parallel and serial calculation at the same time. When you're going up to test to become a radio amateur, you are going to have some math on resistors, capacitors, spools, and all that kind of stuff. But I want to show you because the Norwegian book is, I think it is actually quite difficult to do the formula that's in the book. I don't know how to use fraction and dividing by all that kind of stuff. I just don't know how to do that. So with a little bit help of my dad, I were able to understand that you can do some very complicated math very easy, because the formula that I was taught how to use and I refined it on how you're making the calculation is that you can use a calculator at the test. You don't have to use like fraction calculation in your head and all kind of stuff. So the book, I believe, is, I wouldn't say it is wrong, because you can use a calculator and therefore you don't need to learn a complicated formula. I think my formula is simpler to use. All right, so I like Paint. It's a great tool of illustrating stuff, but what I have here is this. I can just move myself to right. I have a three resistors in parallel that I have to calculate, and then so I have to do the calculation of that one first to become one resistor. And then it's a formula, I'll show you how to do it. It's actually quite easy. And then you're taking the sum of these plus that one, and then you will have a total resistance number. This might actually be a question on the test. You don't know, but this is quite easy to learn how to do. So it looks kind of complicated, so but I'll be as simple as possible because this is a simple formula. So what I will do first is to calculate the sum of 1.2 kilo ohm, the 5.4 kilo ohm, and the 8 kilo ohm. The sum of that, so it will be one resistor because the battery see those resistors as one, not three. But it sees everything as one regardless because it's serial. So what I will do is to take what I'll do, I multiply these three at the same time. So it will be 1.2 multiply 5.4 multiply 8. And then you have an equal sign. So, but make sure that everything is also on the same value, like kilo or ohm or mega ohm. Just have everything in one. You have to do that conversion first. So what I will do here, I have a calculator, because you can use a calculator. For this one, you don't need a scientific calculator. But what I will do is 1.8 times 5.4 times 8 is 51.84. So 51.84, that's the number. So this number is actually quite important. Now here's what I believe is simpler. You have to do 3 operations in order to get this to work. So I'm taking 5.1 divided by 1.2. So 51.84 divided by 1.2 is equal 43.2. 43.2. Let me double check that, because if I have one number wrong, I will have everything wrong in line. So 51.84 divided by 1.2. Yep, is correct. Perhaps sometimes just double check if you're not sure. Do the math again. So the next one is 51 51.84 divided by 5.4. So I'm clearing it out. So 51.84 divided by 5.4 is 9.6. 9.6. Then the next number is 51.84. 51. You see where I'm going with this. 51.84 divided by 8 is 6.48. So 6.48. So the next step is not complicated. What do I do next? It's actually very simple. I add them together. So plus sign, then another plus sign. I'm also going to have an equal sign here as well. And I also need another equal sign because I'm going to show you something quite interesting. This math actually works. So I'm taking that plus sign, place it in there, and the same here as well. Then I will have a new number when I'm doing this. Just don't be confused right now because it's actually quite easy. And I can prove that this is actually working. So what I'll do is 43.2 plus 9.6 plus 6.48 is equal to 59.28. 59.28. And this is not kilo ohm or mega ohm or whatever. It's just a number based on these values. So it's totally okay. What I will do now is to find the total resistance, and it will always be lower than the lowest one. It will be less than 1.2. I guarantee it will be that. So what I will do is to take 51.84 divided by 59.28. That will be the total sum of these three. 59.28. Oh, sorry. 51.84 divided by 59.28 is equal to 0.74. 0.874 kilo ohm. This is a kilo ohm right now because the other numbers are in kilo ohm. I don't have the sign for ohm here, so I'm just gonna leave it that way. So the sum of these three is less than the lowest of one of the three. So it will, in this case, is 0.874. So this is the parallel calculation of the parallel resistors. So now you have three resistors. You have a 4 kilo ohm resistors, and you plus them 874 plus 4, then you have an equal, and that's the total resistance you have in that circuit. It's really easy. It's really easy. So 4 plus 0.874 plus 4 equal 8.874. The math checks out. I've been testing this so many times. It works every single time. It's really, really easy. So the total resistance in this circuit is 8.874. I made a simulation of this number. I have exactly the same resistors in serial and parallel, and when you're checking on the alright, let me move my picture over. So when you're checking your resistance on the battery in the circuit, in the down right corner you see a number R, which stands for resistance, and that is, what does it say? 8.874 kilo ohm. It just checks out. Every time I'm doing this formula, it actually works. And you can use, now here's the trick. When you can use the same formula and the same setup when you're calculating capacitors, but when you are using serial capacitors, you are using the same type of formula as I do. And when you're using parallel capacitors, you're adding them together by capacitor 1 plus capacitor 2 plus capacitor 3 equal capacitor total. And so that's what you have to do. Plus them together. Don't use this formula yet. When you have 3 capacitors in serial, that's when you're using this formula. It's actually really, really easy. So I wanted to show you guys how I did it. It's quite possible that you could get this on. You have to do this type of calculation on the test in Norway. Perhaps you have to do this test in any other countries as well. So I wanted to contribute back into the ham radio world on how you do complicated math very simple. I'm not a math genius. I really am not, but when I see an opportunity to shorten things down, I'll do that. Why do you have to do things complicated? This is working. All right, so that was everything I have today. So Lima Bravo 6 Quebec Juliet is signing off. This frequency is available. Bye bye.